Good afternoon, my dear students. How are you, my dear students? I'm fine, and I hope you all fine. Yesterday class we discussed that preparation of hydrogen and preparation of deuterium, tritium, physical and chemical properties of hydrogen. Today's class we are going to discuss the chemical properties of deuterium and tritium, uses of hydrogen. Okay, so the chemical properties in deuterium we denoted here D. Like hydrogen, deuterium also have the reaction with oxygen. That means it undergoes the oxidation reaction. Deuterium undergoes the oxidation reaction. So, oxidation reaction of deuterium, two molecules of deuterium atom is combined with oxygen molecule and it's produced 2D2O, heavy water. So this is the oxidation reaction of deuterium. The second one, reaction with halogens. Halogens, what are the halogens you have? Fluorine, chlorine, bromine, iodine. Generally we denote halogens are X and deuterium is D. When deuterium is combined with halogen, it may produce the deuterium halides, like the reactions. Deuterium molecule is combined or it is react together with halogen atom, with the halogen molecule. Now the product of this reaction 2DX, two molecules are deuterium halides. X is fluorine, chlorine, bromine, iodine and astatine is X. The third reaction, third chemical properties. So totally we have two chemical properties of deuterium. First chemical property is oxidation, second chemical property is reaction with halogen. And the third chemical property is deuterium exchange reaction. Deuterium exchange reaction. From the heading you can understand deuterium exchange reaction. So deuterium can exchange the atom from the reaction. So this is called generally deuterium exchange reaction. Deuterium have the capability to remove the hydrogen or to exchange the hydrogen with the deuterium, either partially or completely it can remove the hydrogen. It is only depend upon the condition of that reaction. So the reaction is occur in the presence of deuterium or heavy water. So take for deuterium exchange reaction example, take a hydrocarbon methane and it is treating with the heavy water or in the presence of deuterium, you know that. Okay, so we treat this with deuterium. So what is the process? Deuterium exchange reaction. So deuterium is exchanged with the hydrogen. It is exchanged with the hydrogen. Now this 4 hydrogen is exchanged with the deuterium. So the resultant C and hydrogen is exchanged by deuterium. Totally how many deuterium are present? 4. 4 hydrogen is exchanged with the 4 deuterium. So the resultant CD4 plus this removed hydrogen are formed the byproduct 2H2. 2 molecules of hydrogen molecule. 2 moles of hydrogen molecules is produced. And the example, next example, 2 moles of ammonia is combined with 3 moles of deuterium molecule and it's produced or the exchange reaction result is deuterium is remove this 6 hydrogen, totally 3 into 2 6 hydrogen. Here you have 6 deuterium. So this 6 deuterium is exchanged with the 6 hydrogen. What are the resultants? 2 Nd. For hydrogen, we fill there D. So D3 plus how many hydrogen is removed? Totally 6 hydrogen. So 3H2. This is one of the important question, 3 mark, or maybe they may ask 2 mark also. Okay. So with the example and the theory, you should write this. Next is properties of tritium. So you learn the properties of deuterium and protium. Third isotope is tritium. Tritium have a special property because it is a radioactive element and it is reacting as a beta emitter. Beta emitter means beta rays is emitted from the tritium molecule and their half-life period is 12.3 years. And the emission of beta rays by the reaction tritium produce helium isotope, and its release beta rays. Next is uses of hydrogen. So we have some uses of this hydrogen. First use, we use this for preparing ammonia by Haber process. This is one of the most important process in the industry to use the ammonia by hydrogen. So Haber process is synthesis of ammonia by hydrogen in large scale in industries. So over 90% of hydrogen is produced in the industry only, and we use this for the many synthetic applications. One of the synthetic application is Haber process. Haber process means to synthesis of ammonia by using the hydrogen. So ammonia is an important chemical to use to prepare the chemicals such as nitric acid, fertilizers and explosives. So hydrogen is playing an important role in the industries. So the reaction of Haber process, nitrogen is combined with 3H2 in the condition, under the condition 380 to 450 degrees Celsius, and the atmospheric pressure 200 atmospheric pressure, in the presence of catalyst, ion catalyst. To motivate this process, we used here ion catalyst. These two are combined together and they produce ammonia as a product. So this is one of the most important use of hydrogen. And second use, we can use this for industrial solvents. For solvents like methanol, methanol is one of the most important solvent we use in the industries or in the laboratory. So for the preparation of methanol, we use carbon monoxide plus hydrogen. Carbon monoxide plus hydrogen, in the presence of copper catalyst, they produce methanol, CH3, totally 4 hydrogen and 1 carbon, 1 oxygen. CH3, 1 carbon combined with 3 hydrogen, remaining one hydrogen and one carbon. So one oxygen and one hydrogen. Okay, so CH3OH methanol is produced with the help of hydrogen. Third use, the unsaturated fatty acids or fatty oils can be converted into saturated fats. Like we already learned this in the addition process. Like that, vanaspati we use in our domestic uses. To prepare the vanaspati, we unsaturated fatty acids are converted into saturated fatty acid. That means vanaspati is formed with the help of reducing agent platinum and hydrogen for vanaspati. Next, in the field of metallurgy, we use hydrogen for reducing many metals like oxides to metals at high temperature. For example, metal oxide is treating with hydrogen, copper oxide treating with hydrogen at high temperature. It's produced metal and removed as a water or moisture. Then tungsten trioxide is combined with hydrogen with high temperature, or it is reduced with hydrogen with high temperature, is produced pure metal tungsten with moisture or water. This hydrogen is used here to produce torch, like oxyhydrogen torch, this is used for cutting and welding. So oxyhydrogen torches. Next use, liquid hydrogen is playing important role in our space research. It's used as a rocket fuel. Okay, liquid hydrogen is using as a rocket fuels. Hydrogen is using in a fuel cells for generating electrical energy, and for the reversible uptake of hydrogen in the metal. It is also attractive for the rechargeable metal in the hydride batteries. Okay, it is also for the rechargeable. Metal hydrides. These are the uses of hydrogen in our daily life, in the economical wise and also in the industries, then scientific field also. Hydrogen is combined with many elements and is produced some compounds like water and protein, biomolecules, carbohydrates. Okay, first the compound of hydrogen, we are going to see water is a compound of hydrogen. Because hydrogen is combined with water, it's produced water molecule, combined with oxygen and it's produced water molecule. This is the compound of hydrogen. Water is playing a major role in our life. This most abundant compound of this water is hydrogen, and approximately 70% of ocean is in our earth. It's a major source of hydrogen, and it is the major source of water also. But sea water we can consume, we can't consume that directly, but we can use this by purifying method. We can easily use this water. So water is the essential one for all living things, and for our body, also, for humans and all the living things. Water is the essential one, and our body contain about 65% is water. The shape of water is oxygen, hydrogen, hydrogen. So the angle between that two bond 104 degree, 104.5 degree. This is shape of water. What are the physical properties of water? Water is a colorless one, and it is a volatile liquid. Colorless, volatile liquid. It contains internuclear bonding between hydrogen and oxygen. Hydrogen bonding is the responsible for high melting and boiling point of water. So some physical properties of the water is given in the below table 4.2. In the table 4.2, you can identify the difference between protium water, deuterium and tritium water. So the molecular weight of water 18.015 protium, and deuterium 22.028, for tritium 22.0312. The melting point is also different, and the boiling point also it is different from the for each water. Okay, now let's see the melting point. 273 for the normal water, 276.8 for deuterium, and 277.5 for tritium. Then boiling point 373, this is 374, 374.5, this is 374.4. The temperature of maximum density, so the density of this water in the temperature 277, deuterium 284.2, tritium 286.4. The maximum density 1, here 1.1, here 1.2. The density in the vapor pressure is 23.75, 20.51, 19.80. The velocity is given in the list. This is not applicable for tritium because that is only a trace amount. Velocity is not applicable for this tritium. Viscosity is not applicable for this tritium. And the dielectric constant is given in this one, and the enthalpy of formation, bond formation, enthalpy or the energy for the bond formation, and the enthalpy of vaporization, that means energy for to vaporize the water molecule, this energy. So physical properties is over. Next, chemical properties of water. So the chemical properties from the water can react with metals, non-metal and also other compound, but in a different way it can react. So most of the reactive metals like alkali metals, what are the alkali metals? Lithium, sodium, potassium, rubidium and cesium. So these are the alkali metals. So it can react with the alkali metals, and they decompose the water. The alkali metals decompose the water, and so the reaction with reactive metals, sodium is combined with water, is produced sodium hydroxide, evolves hydrogen. This is the reaction. This is first group elements. First group reactive elements reaction. Then second property is reaction with second group elements. Reaction with second group elements except beryllium. Except beryllium. Water is reacting with the second group elements other than beryllium in the similar way, but they are less violent. But in the group 1 reaction, when treating water with the alkali metals, they reacted together violently. But in the second group, it's not more violent, it is less violent compared with the first group elements. So the reaction for the second group elements, barium plus water molecule, 2 molecules of water, and is produced barium hydroxide, and it's released the same one how the alkali metals are reacting with water, they release hydrogen. Like the same here, this second group elements also reacting with water, they release hydrogen and they leave the hydroxide solutions. So the hydroxide solution which is formed in the second group reaction, it is less soluble than the first group reaction. That means first group reaction, first group hydroxide are soluble, more soluble than the second group reactions. Third properties. So some transition metals are reacting with the hot water, or it is reacting with the steam to form the corresponding oxides. So transition metals, for example, iron. We took here iron. 3 molecules of iron is combined with 4 molecules of water, and it's produced here Fe2O4 plus 4H2. Same process is going on when transition element is combined with water, and they produce hydrogen as a byproduct, or it's released hydrogen as a gas evolves. And the fourth chemical property of this water, coming to the third one. So in the third one, transition metals are lead and copper decompose in water only at white heat. Silver, gold, mercury and platinum, does not react with water. So the other compounds like non-metals, carbon, sulfur, phosphorus are normally in the normal, they are not react with water. But we know that carbon is reacting with the steam, and they in the presence of red hot coke, they given the water gas. But halogens are reacting with water, they can give an acidic compounds, acidic solution. Halogens with water, they produce acidic solutions. For example, chlorine form hydrochloric acid and hypochlorous acid. It is the halogen chlorine, it is combined with water and they form hydrochloric acid, hypochlorous acid. Hydrochloric acid and hypochlorous acid is antibacterial one, and the chlorine water we can use this, and as a bleach we can use this hypochlorous acid. Reaction for halogen with water, it's release hydrochloric acid and hypochlorous acid. So this is using as a bleach and antibacterial action of chlorine water. Then fluorine is reacting with water. Fluorine also halogen. So fluorine is reacting with water and it is liberate the oxygen from water. This is the reaction. So fluorine reaction with water and it is liberate hydrogen, it's produce hydrogen fluoride and it's liberate oxygen as a gas. Next, chemical properties. The non-metals reaction with metal reacts with water. It gives acidic solution or alkaline solution. So non-metals are react with water, they can produce the acidic or alkaline solution. For example, carbonate are slightly alkaline. So if you treat this carbonate salt with water, they can produce HCO3 and OH minus. So this is one alkali solution because of treating this non-metal carbon with oxygen, it's combined with water, it's produce alkali solution. So as you know that already, water is an amphoteric acid. Why we call this as an amphoteric acid? It have the ability to accept the electron and also it can release the electrons. So because of this ability for releasing electron and accepting the electron, it can act as an acid and as well as base. For example, we can treat this reaction with hydrochloric acid, accept the proton, whereas reaction with weak base ammonia, they donate the protons. So first reaction, hydrochloric acid with water. Why? Because water is an amphoteric acid, oxide. So amphoteric oxide, this can donate the electron and this can accept the electron. So first one here, it can accept the protons. How it is accepting the protons? Hydrochloric acid combined with water, it's form H3O+. O plus is the release acceptance of protons. Proton is accepting and Cl minus, chlorine minus. And the next reaction for releasing or donating the protons in the presence of, in the reaction between ammonia plus water. Ammonia is reacting with water, it forms ammonium ion, and they produce OH minus. So it is donate the proton, and water is dissolve the ionic compound is the next chemical property. It can dissolve ionic compound. And as well as it hydrolyze some covalent compounds. For example, SiCl4 with water molecule, it form SiO2 plus 4 hydrochloric acid. SiCl4, 4 chlorine, 4 hydrogen, combined together 4 hydrochloric acid. Silica with 2O, so SiO2, silica dioxide. Then P4O10 combined with 6H2O. It dissolves the ionic compounds and also it hydrolyzes the covalent compounds. 4H3PO4. It is dissolve this ionic compounds like SiCl4 and it is hydrolyze the covalent compound. How? Combining together P4O10, P4O10, 6H2O, they are combined together 4 molecules of H3PO4. Okay, up to the chemical properties, we have only 2 chemical properties left. You can look at this at next class. Today's class is over. Thank you, students.